Now man comot early last year.
No, that woman, you don't let this one.
That woman no fit do such.
No, wait then.
I see
Should
it,
have-
Nasir, before. That is the first sequence in on-off.
First sequence.
The first sequence is on-off.
On off.
Yeah,
Yes, and then comes the second, third, and so, you know.
in mine too.
Where have you seen? The
In the
here.
schematic. No, brother, in the schematics.
I
No.
can show you in my schematic.
Yes, please show us. Yeah, that means that is this.
Here.
That's yes.
1, 2.
See it.
Yeah,
Yeah.
same way in mine.
Yes,
No,
yes.
actually, one thing is here that yes, of course, I think here I have written 1, 2. This
Yeah.
is something.
Main
Look,
power button.
no. Actually, you have not understood one thing. What I mean to say here only that after what I have to achieve from here, I have to achieve SLP S3 from the PCH, SLP S5 I have to achieve from here, SLP S4 I need to achieve from PCH, I have to achieve S0, last S0 I have to achieve. And in order to achieve, I have not to care that what could be the sequence. First of all, how should we follow? That the thing which I am required, like always on to achieve the on off. Like I have given you example that in my laptop, but I have received the Vegas, and that Dell was not having the always on. What I have done, LDO I have connected to enable this one, and it is also connected to 5 volt, and I have achieved 3.3 and 5 volt. Okay, but despite laptop was not turning on. Why?
Because you still need that PM
No,
underscore
no,
power
no.
button hash. No?
If you see this architecture, you have seen that where is the Vegas? Yes, this one. You have seen that you need to have 1 volt, you need to have 8 volt, also it's power good. You need to have 5 volt, 3 volt with power good to achieve RSM reset. So merely I have to complete the voltage is not enough. If you have voltage 3.3 volt, and if you are after triggering, after turning on, even it is showing you that it is triggering and it is going down, is that enough to turn on the laptop? No. Actually, in fact, what things you are required, these are the sequence when you have before turning on. These are the things before turning on, even it is written or not written in any schematic. That is why I'm telling you again and again that you may have the different types of architecture. Look, in every architecture, do you have the adapter ID? No, not at all. In HP, you may have the adapter ID. In Acer, you may not have. So that is the thing you have to understand. That is why again and again I'm telling you, don't memorize. Only you have to memorize the importance of the signal. That what is this and when should I get it? Like if RTC is okay, it will be high. Whether you turn on, you don't turn on, you should get it high at any cost. And these things, yes, this one you have told right. You have told me right. After turning on, as soon as now the sequence is started, 1, you turn on, 2, the debounce logic you will get. This is the 2 number you can say here. In the matter of turning on, these are the things before you will get. If these things you are not getting, like RSM reset may be low in some cases, in some of the cases, but after turning on, it should not have glitch as it is written on the data sheet, PCH data sheet. If it is low, in very rare case you will get it is low, and after turning it, it will go high. In some of the cases, maybe 5% of the cases, that is very less. But in 95% of the cases, you will get high. And how will you get it high? through the D power okay, or through the 3.3 volt and 5 volt power good. So as of now, before turning on, before this sequence, I should have these things. Got my point?
Yes, sir.
Any of the architecture, any of the motherboard, even I don't have this. Most of the time, what do I open at my office? This one. These are the things. The same whatever I'm teaching you, because I know that most of the common ICs are used in these one. Look, if any laptop is having 9012 motherboard, I open this model, because I am concerned with the only IO. And you should also check like this way. Okay. So what you have to find, you have to find the same way, that these things before the turning on you should get. And now after turning on, now the first point come that power button. You should get power button with the debounce logic. Then PCH will respond. It will wake up. However, it is also known that resume reset, but this is only to resume. Now sus on will be released from the PCH.
To the IO, yes.
Yes, and it will go to the IO. And in some of the architecture, you may have this one. If you have on-off button name NBSWON, notebook switch on, if this types of signal you will get, then you must have DNBSWON, this signal hash. Notebook switch on, then deep notebook switch on will come out from the IO. Got my point? After turning on, after pressing the on off switch button, you must get 3.3 volt, the same logic, the debounce logic on the DNBSWN. Got my point?
Yes, sir. Debounce. And this is NBS1. Notebook switch on. Hash on the power button. And we get the deep notebook switch on.
Take it. Now, the two signals are, I'm leaving it just because here is the two signals information, because I have very less space here. You should write it. And what will be consequence if these signals you won't meet? This is the sus warn signal, and this is the sus ACK. This is the sus acknowledgement. This signal name is the sus acknowledgement, and this is the sus warn. When PCH thinks that I have to go into the sleep mode, when you leave the laptop, and when it is decided to go into the sleep mode or S4 mode or S3 mode, then before going to this state, before going to these states, it will before send sus warn signal to IO to inform that we are going to sleep mode, you just be prepared. And if it thinks that yes, now PCH is considering to go into the sleep mode, it will say, okay, you can go.
Okay.
Got my point? And if you see one more important thing, I have repaired this types of problem. However, it is very much critical problem. It is very markable that see here hash mark. It indicates you that activation is active low. It means the activation is low. So when it considers that if it is going to the sleep mode, it will low this signal to inform SIO. To lower down this signal from high to low to say that I am going to the sleep mode. It will behave like the same way. It will high and it will say, yes, you can go, like this way. So you have to check, there must be 3.3 volt pull up on this point. Otherwise, you will think that their laptop is having no display, and actually it is no display. It is on the sleep mode. If you have no voltage on this pin, your laptop will keep on thinking I am on the sleep mode. Yes, sure.
But is it just the screen that is being affected, or everything after this number 8 is a problem now?
Actually, you know probably very well that CPU requires a 0 state to work.
Okay. Okay.
CPU state is required C0 or C1 state. However, there are other
Okay.
C10 state as well. But let's only talk about the C0 and C1 state. CPU has the C0 and C1 state to work.
Mm-hmm.
So that is
Okay.
the full on state. As we talked
Perfect.
about that, the voltage state is the S. You can begin from the G3, G1, G2. Also,
Yeah, graphics.
We also know S5 only. Merely we know S5, S4, and S0
Three.
state. So
Okay, yeah.
in order to work properly, we are required S0. Every
Okay.
voltage we are required in S0 mode.
Yes, sir. Perfect.
So look here, if you have a low signal, if you have sus1 and sus ACK low signal, then PCH will automatically, or the management will send it into the sleep mode. And what does happen in sleep mode? That the laptop is not on the S0 state. First thing, the CPU will delatch the clock, CPU will delatch to RAM, everything will be delatched for the time being. It means there would not be communication between the PCH and CPU. There would not be clock. Everything will be halt. So that is a kind of no display. Like your processor is not working, like as you have not using RAM, like that type of no display. It is not like that you are not having display on the only screen. You may not have display even external on the keyboard. Okay. So these are the transferring state. State transfer means that voltage is not in the S0 state. In one example only, you can understand this thing. See here.
Joe, don't smoke.
See one thing. Your S0 is required to on to what? Like here I am required GFX voltage, like core voltage. These things we are required. See here, in S3 mode, it is off.
Yeah.
So if it is, your laptop is thinking that I am S3 state, how can you think that you have the core voltage on your motherboard? Because that signal works is to transfer this state to this state, and this state to this,
Yes.
and go back to this state to this to this. This is the work of that signal. When it is low, I never need low that signal. I need high. So you can pull up from anywhere. If you don't have the voltage on that signal, pull up a voltage from anywhere. I don't want to go into sleep. Keep on waking like me. Got my point?
Yeah.
With this pull up the voltage from anywhere, you mean really from anywhere, from laptop, from motherboard?
Exactly. Yes, I'm not joking. Especially
Okay.
when I teach, I don't joke.
Okay.
Look, one thing.
Okay.
Yes, actually, you need to only know sus1, sus ACK, SUS, sus WA. What is the name? sus1.
Yes, Suswarm. Yes.
I think I am not getting this.
Maybe, yeah.
WARN,
Yes,
sir.
yes, 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 yes.
WARN.
See here.
Oh, he write it right down, but it's not there. Yes.
Yes.
Suswan. Yes.
See, 3 volt, 3.3 volt PCH is pulled up. This is the S0 state. This is the S0 state. S0 state voltage has been taken. However, this is not the S0 PCH. This is the 3521 motherboard, and the responsibility of this voltage is from the PCH on signal from the IO, which is equivalent to S4 state. I'm telling you, if you have no voltage on this point, if you have no voltage on these points, you can have pull up, because I will tell you when you don't have the DRAM reset from where you have to pull up on the S0 state to S5 state. So we will do some manageable things here. Only thing you have to check after turning on, you should have the 3.3 volt on the board terminal, sus1, and if there is a sus ACK. Sometime, one more thing here, sometime you may not have both signal. Where it has gone? Which one was that? I think this one. Yes. Sometime what does happen? It is not taken all time. Exception. I am making a star here. Exception. Because most of the time it is not used. This is the master. This is the slave. And master will just command only, and it has to listen this command. So sometime acknowledgement is used, sometime it is not used. So this is not required signal. As per the architecture you have to follow, but this is something which always you will find. Sus warn. Now, so you can write down, because I will not going to write this signal on my sketch. Okay. So sus warn role is to send the laptop in the sleep. This is the information from the PCS to the SIO. Is that all right?
Yes, sir.
Anybody has dot?
Write it long before. Yes. That's okay.
Okay. Now, after this acknowledgement, then PCH will release SLP S5. If it has, some of the architecture don't use SLP S5. Instead, they use SLP S4. So you can write it like this way: SLP S5 slash maybe if it is not having SLP S5, then SLP S4. Like this. I am going to write this. Then PCH will release SLP underscore S5 or SLP underscore S4. It will release like this way. Okay. And now, and we are going to begin the new chapter. I am going to move forward, and we will start from the SLP S4, because now the story begin. Yes. When it receive SLP S4, it also go somewhere. Whether it is, you can say SLP S4 or SLP underscore S5. Where does it go? It go to RAM chip. Now your RAM will start. On the RAM chip, it will always go, you will see there would be written S5 on your RAM chip. I'm talking about inside the RAM chip, a RAM regulator, there would be written S5. And S5 is responsible to release VDD-Q voltage.
What? Sorry, is this a coil or what is this?
RAM.
No, on the right side from the RAM.
This yes,
This is-
coil. This is the coil.
It's a coil.
This
Yes.
is the RAM regulator. This is the RAM regulator. Like if DDR3 RAM regulator, it is having a 1.5 volt. And if it is the DDR3L, this is the 1.35.
3.5, yes. And if
So
the
this is the,
DDR4,
yes, if DDR4 1.2 volt, you can say.
yes,
This is
yes.
the coil.
Mm.
It's not look like coil.
No, it looks like coil. It's right. It's right.
Yes, okay,
Everything.
good. Now,
Okay.
so after receiving this signal, maybe that sometime, this is the one architecture that after receiving SLP S4, once it will go from the same way, it will reach to the SIO, and also it will go to enable the VDD-Q RAM supply, main RAM supply. And in some, this is the one fundamental thing. This is the one logic. And some of the logic you may get if you are not having this one. If you are not having this one, then definitely the second logic you will get, then it will release a voltage which is known, what is known? System on. System on.
It's on.
Sys on. Instead, look, there are the two ways to enable the RAM. This is the very same thing.
Mhm.
Got my point? Either it will use directly SLP S4 to enable the RAM. It will also go to the SIO. Or it will not go here. It will not go here. It will go to the SIO, and SIO will release a signal that is the system on,
This one, yes.
and it will go to
The RAM.
the RAM. RAM will start the RAM voltage. Got my point? Prabdeep, any
Yes,
point?
sir.
Any confusion?
No, sir.
They are the two architecture. Like here, I am having two architecture. Both architecture I am having here. See here. This is the HP model, and how we are going to see here. 10 number is SLP S 10 number. See here, mark. 10 number is SLP S5, and the 11 number is your system on. Okay. So after receiving SLP, you can think it SLP SLP underscore S4. SLP S4 and both are equal. SLP S4 IO has received, and then IO release system on, and then we got RAM voltage here. Okay. This is the one kind of architecture. I'm just following the architecture. Not even I will recommend you to follow the same.
Stop.
Yes. Yes. Sure.
Stop. No. Please, previous photo. So one on the left side, 1.345 volt. This is DDR3 low, and under is 0.675 volt.
Yes,
What is this?
Yes, I'm coming on that. I'm coming on
Okay,
that.
okay.
I'm coming on that.
Thanks. Good,
This is the one point. This is the just SLP S3. Sorry, S4.
Four.
I haven't completed yet.
Okay.
I think where is the this one Vegas C1. This is the one kind of architecture. Directly we see in some of the architecture SLP S4 is going to be enabled for the RAM supply, and now after 3A started. That is the RAM supply. Got my point? This is the RAM supply. 1D35 volt. There is nothing between. Like it is not like this way that the PCH will release a signal SLP S4 and then it will release some signal. After some time, like here power button, after power button, as we have stopped after power button, and we have seen that sus warn signal. Just skip the sus warn for the time being. After power button, PCH release SLP S4 and it reaches to the RAM regulator and it release the RAM voltage. That is VDDQ. Got my point?
Yes.
Some architecture directly S4 would be, and if you find this IC, there must be written S5 inside the RAM IC. Always. In every architecture. S5 is enabling for the VDDQ. And now let's talk about the SLP S3, where it has gone. Yes. See, in some architecture, you will find SLP underscore S3. SLP underscore S3 hash. How can I forget this? Yes. Or it will go
Yes.
this way. Here it will be written S3. It is VTT enable.
This is
Enable VTT. This is the memory, CPU memory power supply. You can say the RAM, actually VTT is one of the power supply required for the CPUs inside the CPU, the cache supply, you can say, which
What
you
to
can,
say?
cache memory. The CPU cache memory, you must have heard the 2 cache memory, 3 cache memory. That memory is required this voltage. And this
Okay.
is half of the VDDQ, half of the VDDQ.
Always
Half of the VDDQ.
are from
Got my point?
yes, sir.
If VDDQ you are having 1.5 volt, you will have 75, 0.75. If you have
Yes.
DDR4, then 0. You are asking that what was that? So now
Oh,
that is,
everything. I know everything. Very fine. Fine. Thanks, Nasir.
so this is the one number in the sequence. In the sequence, this is the one number and this is the 2 number. And one architecture, ARC. This is the one architecture that directly it could be happen, and this is the second architecture, ARC architecture. And this is the one kind of architecture. And this is the other type of architecture you may have, that if directly it is not going to the RAM IC, but through the SUSP hash. SUSP hash. This signal you may have to enable the VTT. RAM has the two regulator. One is the VDDQ and one is the VTT. Got my point?
Yes.
Like if you have gone through the 3.3 and 5 volt regulator, there is the one requirement that S5 on or something. One enable is for the 3.3 volt as far as for the 5 volt.
Yes.
That is the one architecture. Now RAM has the different architecture that it has 2 requirements to enable. One is for VDDQ and one enable for VDDQ, which minimum requirement is SLP S4. Or if directly it is going to the RAM chip, then it's okay. And if directly it is not going to enable the RAM VDDQ, then it will go to the SIO, and SIO will release, maybe sometime you will see system on, main on. This type of name has sometime also one name.
Main on. Okay. 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 Very good.
Okay, I am skipping from my mind. Okay, system on, main on, and these types of name you may have. you can find easily. You go on the RAM IC and see what is coming on the S5. You will come to know.
Okay.
Definitely it would be coming from the RAM. After getting, when it will release, like if your laptop is not releasing main on and system on, then go back and see that your SLP S4 is reaching to the IO or not. If you are not getting the SLP S4, go back and check your power button auth is released from the IO or not. If there is no power button, you go back and check the RSM reset and depower OK. And if depower OK is not okay, then go back and check the RTC once again.
RTC section, yes.
Like this way. Then this is susp. Now it is like that, this way. And after releasing SLP S3 on the 12 number, and you have 13 number susp hash. In compal motherboard, where LA number, mostly you will see these types of architecture, susp and system on. In compal, you will see these types of architecture. But maybe in Western and in different architecture, you may have the direct SLP S5 on the RAM IC. Got my point? I think this must be okay for today.
It is okay.
So
It is
now,
enough. Saya, it's enough, really. I cannot have more input into my brain. Sorry.
okay. Don't worry. If you have understand, then it's okay. Otherwise, once again,
Yes.
I will go through this, because
Oh, very
these are the things you always have to check in the motherboard, and these are the things which helps to find out that where is the exactly problem. So now, Pradeep, have you any question regarding this or apart from this?
Sir, right now it will take me some time to get deeper, because there were a few things, because while you were teaching, I was also looking at my power state diagram just to correlate what was going on, like, you know.
This is what one thing I would like to say only regarding this. Look, I have seen thousands of schematics. Maybe that you will also see the thousands of schematics. And what I rather follow, I follow the architecture. Like, as I have told you that in the compile, you will always find susp. Most of the, in HP and Dell and in most of the laptops, you will find susp. So this can mismatch. I am damn sure about this. It can mismatch. I have the various types of power diagrams here. So I have shown you even in some of the architecture, in the very architecture with the battery is the different and with the AC it is the different. So,
for sure, yeah.
But what should be the basic architecture which you are expecting in the motherboard?
Yeah.
I'm not talking that whether you have the schematic or you don't have the schematic. I'm just talking that casually that in general, in most of the laptops, what you will see the same type of common things you will find out. The thing I am writing, the only things.
Yeah.
Those things I'm writing here, that you just don't compare that. Okay, I have told you in the 5 number and you are giving me in the 10 number.
No, sir. Not like that.
No, that is the things when in the different architecture. Like if you talk about the PSL logic, you will one sequence has been increased there.
Yeah, I see.
So maybe that the number would come later of S5 on will come later on after the PSL logic. You may vary the power sequence.
Yeah.
So but the most common power sequence I have written, because what I am expecting from the motherboard, the RAM voltage after turning on. After turning on, I am expecting RAM voltage from the motherboard, VDDQ. And after VDDQ, I am required something, which I will tell you. I am required a 0 voltage, 3 volt, 5 volt. The sequence I can tell you in rough that what you expect from the motherboard. I am expecting in the voltage, I am required V gate voltage, core power good I am required in the power section. Then the communication will start. These are the also communication, but the main processor will start after getting the power good, or you can say that that is the IMVP power good, Intel Management Voltage Processing Power good. After getting
Okay.
that, look, if you follow the my way, one thing is very clear, that supply, all supply. Why I'm hankering after these things, these signals, to achieve the supply. Supply for RAM. Supply is required. In order to achieve the display, supply must be okay from the V gate. For power good. Reset. All reset must be okay. Then signals is equal to display. Got my point?
Yes,
I
sir.
have to follow the same role in any.
Yeah, for sure. Yeah.
And if I have to make supply, if any laptop you give me, I will check, do I
These
get my
things.
VDDQ or not? If no VDDQ, then I will check,
Before.
jump it. No, jump it. I will jump it to the D power okay first. Don't
Yeah,
check.
for sure.
Because
Yeah.
this is not something a child, like after two counting, you have to go to the 3 like this way. These are the signal. Like, you know that what is the role of PLT reset. If the PLT reset, how many things should be okay in the motherboard? If you know this thing, you directly go and check the PLT reset. I save my time like this way. Okay, but sometime it also mislead. Sometime maybe very small thing you leave, and despite you are having the PLT reset, however, that is not the right way to check the PLT reset. Only having 3.3 volt on the PLT reset signal. That must be reset like this way. And 100 megahertz give me don't give me this down signal. So despite I know I can work on this way. And you can have the you can say logic analyzer. You can have the logic analyzer and connect it on the PLT reset. It will show you like this way. I think only $10 to $12 you have to spend to check the PLT reset. So there are the lots of way to checking. This is my smart way. I don't have, doesn't matter. I just check just beside the RAM slot, there would be a RAM coil. I need to have that voltage. I see that what RAM regulator is used. I just type in my schematic, any of the schematic, if I have this voltage, because what I have to check S5. So never follow any schematic, because I have told you one thing. Have you seen that SRTC reset is written in any schematic? If you could show me in any schematic, if you can show me in the power sequence, have you ever seen that SRTC is written? See, only PCH RST reset is written only. No SRTC is not written. But if you have no SRTC, laptop will not come out from the, no, it will turn on. It will not exit from the S4 state. It will not go in the S3 state. It will on. Very light load it will take, but it will not enter in the S3 state.
I see.
It must write here, but it is not written. So sometimes you have to follow, sometimes you don't have to follow this. It is up to you. Yes, you go through so many various types of architecture you should go, and you should see. Also, I'm also looking for that the new C type of architecture. As of now, I am having only one motherboard of C type, and I am constantly looking for, because Apple I receive in the C type, and that is a very different architecture as I have gone through this model. E580, this is having the C type of architecture, which we will also discuss about in the I think in the last, after completing the session, because this is the update.
Sir, less than 1 minute.
Yes, I think do you have any questions, anybody? Then I will send you link, otherwise we will better to sleep.
Not this week, sir. Next week we will ask some questions.
Okay, sure. Okay, then good night to all.
Thank you.
See you in the next class. Good night.
Yeah.
Thank you very
Good night,
much.
sir.
Good night, sir.
Thank you.